So this is 6.5. This is actually the beta gamma lesson. We're going to combine those into one video. But before we get to 6.5, I want to come back to this because this is one of the things on your assessment. This is one of the things on your assessment that wasn't on the quiz. So if you're at home, ready? What was on the quiz was slope fields, Euler, anti-differentiation by substitution, anti-differentiation by parts. Then what we are adding to that for the test would be this, which is separation of variables, fraction decomposition, which is going to be your exit ticket today, and logistic growth, which is what we're going to come back to after we look at these slides. So here's the issue. When you get a problem that looks like this, the change in y with respect to x depends upon x and y. So you can't do a problem like this until you put the x's with the dx and the y's with the dy. Like you look at this problem and you say, you make this association. They give me the derivative, they want the parent graph, so I have to anti-differentiate. You're right. But you can't anti-differentiate that expression because this is with respect to x, and you have a y over there. And what's going to happen in May, and we'll have plenty of time to review this, and how College Board tries to make this challenging is, they don't just give you x's and y's, they'll give you other letters. Because you're kind of like programmed, just look for x's and y's. But what you're looking for is saying, does the letter on the right side of the equal sign match the letter on the left side in the denominator? And if not, you got another step to do. So there's the step. What did they do? They multiplied both sides by dx, and they divided both sides by y squared. Now what? All I did was rewrite that as y to the negative second. Yes? And what mistake are people going to make? Who can think of a mistake that somebody would make between this line and the next line? No. I mean, if they make that mistake, then they just don't know what they're doing. Some people would write that the left side would anti-differentiate to ln y squared. No, I would never do that. What? Very good. You'd only would get ln if the exponent denominator is a 1. Why? Because if the exponent denominator is a 1, you had 1 over y dy, and you anti-differentiated that, and you went to do the power rule in reverse, you would get y to the negative 1 plus 1 divided by that. That's not going to happen if this is a negative 2. Yes? But can you understand that if it were a multiple choice answer, that ln would be one of the choices or more than one? Because people say, oh, it's in the denominator, it's got to be ln. Okay. Power rule reverse. You got a constant on each side. So you don't need to label the constants. You're only going to have one constant. You're going to combine them. Now what? What's the matter with this? Its nose runs and its feet smell. What is the matter with it? It's upside down. You don't want to know what 1 over y is. You want to know what y is. So they took the reciprocal of both sides. Okay? And then what? Well, you're done unless they gave you an initial value. And if you got an initial value, then you would have to put those numbers in for x and y to quantify the constant. If they don't give initial value, you're finished. Separation of variables. Now, the children that graduated in 2019 have a grudge against me. They have a grudge because they were in BC in 2018 when they were juniors, and we hammered them on this separation of variables, separation of variables, separation of variables, and in that year it wasn't on the test. And they all came back into the test going, oh my God, I was so good on separation of variables and I was so looking for that question and it wasn't there. Well, it just happened. Most of the time, you will see separation of variables in the FRQs. Most years. There is a document in Canvas where we outline what was on the test for each of the last 6 years. Well, 5 of the last 6 years, or 6 of the last 7 years, because it does have last years, because the questions were different. But for the 6 years leading up to last year, there's a document in Canvas that will go over the spring to help you anticipate what you're going to do in the FRQs. It is likely you have to do this, but not guaranteed. So here's an example. What do you notice? You just got to separate it. So how do you separate it? You take, there's 3 things multiplied on the right. You take the middle factor that's got a y in it, and divide it on both sides, and then you've got the y with the y and the x with the x. Okay? And we don't need to finish the problem. I'm just saying, make sure you understand how to begin the question. So back to what we did yesterday. Because in addition to separation of variables, again, you have access to those PowerPoints, so you say, well, wait a minute, I want to see how that problem turns out. The Google Slides are in Canvas. You can watch the rest of the PowerPoint again to remind you, to refresh you, because you will get questions. I think there's a couple questions like that on your test a week from today. Okay? So now we're back to what we did yesterday. We went through this PowerPoint, but we can go through it again. But we'll just go through it faster. So what's happening? This right here is the derivative of p with respect to t. There's no t on that side. Yes? So what did they do? They did this. They brought the p over with the dp. They separated the variables. Okay? Why didn't they send the dt over with the k? It doesn't matter they did do that. The point is they separated them. That's the first step. So here's your PERT. And then we told you that we're going to crack the code and show you on the PDF so you don't have to do all this work. But if that's the derivative, which that's how your question would be worded. on next Thursday or Friday in May. The derivative would look like that if it's logistic. Then how do we anti-differentiate it? And my point is, I'm going to walk you through what's up here. You don't have to do it because on the PDF, I did it for you. That this will always be true of the information on the PDF. Because I don't think it's worth it to keep doing this each time. If you can follow it. Oh, do you understand what happened here? Yeah, I get it. They put the P to the left, and then they did multiply both sides by dt. They just didn't finish it on that other slide. Then, well, this is your exit ticket. That's how they got the separation. They got the fraction decomposition in blue. This is the product of the denominator. So they said the sum of two fractions where they were independent denominators. So you had to quantify A and B. That's what you have to do at the end of this period. That process. Okay? So that takes you here. The M reduces. So when you anti-differentiate this, I'm sorry, the M didn't reduce. They multiply both sides by M. So it ended up over here. And then what happens? When you anti-differentiate it with respect to t, that's where that t comes from, because this is mk t to the 0, because t is the variable. So then you go from t to the 0, t to the first divided by 1. So this t is introduced here, and this would be, right, your first degree, the p's, ln p subtract ln and take away. And that's property of logarithms. And then what happened? They took the reciprocal of both sides. And then they take the left and give each term of the numerator its own denominator of p. To get here. Okay, but it's kind of a, who wants to do all that calculus and all that algebra each time? So we're going to show you what happens. The important thing is you know what the letters represent. P is the current population. M is how high this thing can go. And you saw the example yesterday where it was the amount of fish that the lake could support. But you didn't do that problem this year, but that was like a leftover pre-calc problem. And the bears, how many bears would live in this scenario if there was enough food for this many, for so many bears, okay? And this A down here, how did they get that? They went through all the calculus, but I'm telling you, you don't need to do that because we cracked the code for you. A is always going to be this. This ratio, take away 1. So if we look up here from this question, see A is 59, yes? So what does that mean? It means before you took away 1, it was 60. And the maximum capacity is 600. So that means working backwards, how many people were originally infected with this disease? Is that a hard question? 10. Because this is 59. So 59 plus 1 is 60. So it was 600 divided by 60, which is 10 people originally. and 10 people are going to eventually, see, that's why it's one of the choices. 10 people are eventually going to affect 600 people. But if I look here, the maximum, see, they told you A is 59. If we add 1 to both sides, 60 equals. The maximum capacity was 600 divided by the initial value, which I don't know. If I multiply both sides by that, the initial value must have been 10. Yes? Meaning, I get this. You're taking the test next week. You would have this document open. I'm fine with that. I'm not trying to tell you to memorize all this stuff. Can you work through it? So, here, yesterday we did this. We did logistic regression, but I'm not sure that people that were home got a chance to do it, okay? So take out your calculator. Now, this is the problem about the bears. I'm sorry, they're not bears, they're moose. So here's the question, it's example 5. Just take a moment to read the question off here. We're going to build a T-chart. At time 0, it tells you that they airlifted 61 moose into this park. Yes? And the most moose that can survive there is 25 in 25 years. They're telling you it's 1,000 moose. That's it. There's only enough food for 1,000 moose. You know what a moose looks like? Bullwinkle. You know what Bullwinkle is? The famous cartoon moose. Okay. So it says the carrying capacity is 1,000. How do you know that? It's in the differential. This is 1,000 takeaway pig. Which means what? Think about this. When this number is 1,000, yes, you would have 1,000 take away 1,000, which would be 0. And you'd be multiplying 0 times this growth. Well, there'd be no growth. And if this number is 0, then it would be growing at whatever rate it was, which is, in this case, 30%. So, your calculator does regression. You're familiar with linear regression. We also can do logistic regression. So on your calculator, go here. Stat, calc, and put those numbers in a list. 2 lists. And we're going to go stat, calc, P, logistic regression. Right? So you got all these regressions. You're familiar with linear regression, quadratic regression. And we told you the sign regression is no good to us because sign regression is based on different A, B, C, D instead of A, B, H, K. And the A and B are switched. It just doesn't, it's not going to make sense. But what happens when you do logistical regression to your list? Anyone? You get an error message. Give me an error message. Well, why does it give an error message? We give it needs another point. So what we do is say this. We know it's 30%. So we put this point in between the two. 61 times 1 plus 30%, which ends up being like 79 moose. Because the moose were growing at that rate. So if you put this point in between there, so it's 79.3, you'll get this output. And again, the letters, it's not giving you an M for numerator, it's giving you C. Well, you got to kind of figure that out. Right? Instead of 1,000 moose, the model's giving you 1,013. And then what's this number? 1,000 divided by 60, take away 1. It's going to be about 15 moose. Okay? And there's our rate, which is not 30%, but 28% from the regression. It's going to be really close to the model. Okay? So one more thing. We want to show you in the textbook, and then we'll do the exiting. So we're still on the moose problem. Right? And here's them doing the moose problem. Now look what they got. See this number right down here? There's the final answer. That's the final answer. And here is our answer. We got 15.6 A. They got 15.393. Like doing on the calculus. We just didn't let the calculator do it. They got 1013 for the maximum. 1,013. Calculus took it to 1,000. We get a rate 28%. We get a rate of 30%. Just want you to look at this, and then what happened? They give you a slope field. So the slope field was the derivative. Remember how to build the slope fields? Like one point at a time? So the curve, logistic curve, fits inside the slope field. But just look at here. First line. From here to here, what happened? They multiplied both sides, well, they tell you, both intervals by 1,000. So what did that do? That gave you an integer down here, and then expanded this number on the right. And then what happened from here to here? The last thing. What happened from here to here? Well, you can see on the right that they anti-differentiated, because that's where the t came from, with respect to t, yes? Why did that SIGN change from positive to negative? And this is where, right, they didn't write this all out for you. This is something that, like, I don't really care about for this logistic growth, but this is the attention to detail that should have said to you, like, whoa, why did that happen? I mean, it hadn't said it to me. The first year I took this course, I'm like, where did that negative come from? Because somebody's going to ask me that, and I want to be able to answer the question. But I know where it comes from, and you're the one who's trying to understand this. So you should be saying, well, where did that negative come from? Well, I can't read every single lesson in detail. right, but this is something you should think about. So, I'm kind of inclined not to answer your question. So have you think about it, right? But we're going to move on and take the test. So I would say this. It's because you have this. It's 1 over mu. And mu equals 1,000. Take away p. So d mu dp equals what? -1. Yes? That's where it's negative. Because you need a d mu. So you have to multiply this by -1 and the dp by -1. So when you multiply -1 and -1, you get a +1, which is identical multiplication, but the two negatives allow you to anti-differentiate that mu. All right? So just wanted to take this time. We're going to stop the video.